Hello students, today I am going to tell you about the domain and range of the function. The topic domain, to find domain and range of the function, is very important for class 11th and class 12th as well as for competitive examinations. So today I will take basic functions in which the functions are related to your 11th class and 12th class only. If y is a function of x and f is a function a to b, then what domain is? Domain is set of all values of x for which fx is well defined. Means those values of x which we substitute in function of x, then it remains well defined. Well defined means, I am taking an example. Suppose if I write fx equal to 1 upon x minus 5, or if I write fx equal to under root of x minus 5. So in these type of functions, you see in this function, if x is 5, the value of x is 5, then it becomes not defined, something upon 0, that is not defined. Similarly, in this, if the values of x are less than 5, then it comes negative sign inside the square root, that is again not defined. So domain will be only those values, set of all those values of x for which function remains well defined. And codomain is the set B. Domain is when you say in the language of, suppose, computer, that is input. What input you are giving, that is domain. And what is the expectation? What processing is going on? What is your expectation? That is codomain. Expected values will be from this set B. That is your codomain. And what output you are getting, that is range. So what range is? Range is the output. What value of y you are getting. So suppose y equal to, this is the way to find the range of the function. Suppose y is a function of x, then we express x in terms of y. So range is all values of y for which we get real x in its domain. Those values of x, those values of y which gives you real x in its domain, that will be the range. Now I will be taking some examples which will further explain how to find domain and range. So here are the examples. First example, I am taking fx equal to 2x minus 5, fx equal to x minus 2 upon x minus 3, and fx equal to under root of x minus 4. Simple functions I have taken. Now the first one, you see what domain is. Domain, I told you, the all values of x for which function is well defined. So here you see that you can put any value of x. It will give you well defined value always. So domain becomes all real numbers. And to find range, we write y as a function of x and we express x in terms of y. That is x equal to y plus 5 upon 2. Range is all values of y which gives you real x. So here we see that we can put any value of y. Any value of y will give you real x. So its range is also all real numbers. Now coming to the next problem, fx equal to x minus 2 upon x minus 3. Domain is all values of x for which function is well defined. Here we see that the function is well defined except x equal to 3. At x equal to 3 we get 0 in the denominator. So its domain is all real numbers except 3. And to find range, again let fx equal to y. So y is x minus 2 upon x minus 3. We find the value of x in terms of y, that is xy minus x equal to 3y minus 2. X common, y minus 1 is 3y minus 2. X equal to 3y minus 2 upon y minus 1. So all values of y which gives you real x except y equal to 1. Every value will give you real x. So its range becomes all real numbers except 1. Now coming to this third one, fx equal to under root of x minus 4. We find that domain will be x minus 4 greater than equal to 0. Means x greater than equal to 4. So domain will be all values from 4 to infinity. For all values between 4 and from 4 to infinity, it will give you positive value x minus 4, and that is well defined. For range y equal to under root of x minus 4, x minus 4 is y square, x equal to y square plus 4. Here we see that every value of y will give you real x in its domain. But square root function, as we know, square root function is always taken as positive square root. So the value of this y will be taken from 0 to infinity, means only positive value. That becomes range. So next problem, that is very important one. Fx equal to under root of x square minus 4x plus 3 and fx equal to 1 upon under root of x minus 3. In these two problems, I will explain about domain only, and for this particular question, for this type of problem about the range, that I will discuss in some other video. For domain, x square minus 4x plus 3 greater than equal to 0. Because square root of any positive thing give you a well defined. So making factors of this, it is x minus 3, x minus 1 greater than equal to 0. So product of two factors x minus 3 and x minus 1 is positive when we know that either both are positive or both are negative. So x minus 3 greater than equal to 0, x minus 1 greater than equal to 0, which implies that x greater than equal to 3, x greater than equal to 1. X greater than equal to 3 and x greater than equal to 1, if you find the combined solution, you will find that x is greater than equal to 3. Or the second condition may be x minus 3 less than equal to 0, x minus 1 less than equal to 0. Either both are positive or both are negative. It gives x less than equal to 3, x less than equal to 1, whose combined solution is x less than equal to 1. So we find that the values of x for which this function, this quadratic expression inside the square root sign is well defined, is 3 to infinity and minus infinity to 1. Both 3 and 1 are closed. So domain becomes minus infinity to minus 1 union 3 to infinity. Now for this one, fx equal to 1 upon under root of x minus 3. Inside the square root sign, we see that the term must be greater than 0. So x minus 3 greater than 0. If it is there in numerator, then we would have taken x minus 3 greater than equal to 0. But since it is in denominator, so it cannot be equal to 0. X minus 3 greater than 0, which gives x greater than 3. So domain of this function becomes 3 to infinity open. Means 3 is not included. So that's all. Few problems I discussed on finding domain and range. Now how to find the range of this type of function, that we will discuss in some other video. Thank you very much.